Okay, this is number 70, and the title is Chords. So we already have the definition of a chord on a different note card, but we're going to have some facts about chords today. So here's a circle, and maybe you remember, maybe you don't, it's okay. A chord is a line segment that connects 2 points that are on the edge of the circle. So here's a point on the edge of the circle, here's another point on the edge of the circle. So then the chord connects those. All right, now what happens if there's a point here and a point there, and you connect those? Is that called a chord? So I heard one person say it's a diameter. That's true. Is it called a chord? Yes, it's still also called a chord. All right, so the confusing part is that line is both a diameter and a chord. So there's just two vocabulary words that go with that line. It's a chord because it connects 2 points on the edge of the circle, but it's a diameter because it happens to go through the center of the circle. But then this is just a regular old chord that can't be called a diameter. All right, so I'm going to have a letter here and a letter here. And there's a difference between the straight line that goes from A to B and the curved line that goes from A to B. So if you're at A and you're trying to get to B, there's two paths you could take. You could go straight there, and then that would make a line segment. Or you could go along the curve, and then that would make an arc. So this is the curved path, which is called the arc. And this is the straight line path, which is called the chord. And obviously this path is just a little bit longer than this path. Okay, but they kind of go together because they're both a journey from A to B. So because of that, we call this the arc of that chord. So AB is the arc of chord AB. So all I'm saying is there's the straight line path from A to B, there's the arc, the curved path from A to B, and they kind of go together, so it's called the arc of the chord. It's just terminology that says, hey, they go together. All right, then if you have another chord over here, and I tried to draw that so that they would be the same length. I don't know if I accomplished that perfectly or not. But my idea was to have two chords that were the same. And there's a theorem that goes with that then. So it turns out that if chord AB is congruent to CD, so if they're the same size and shape, if they're the same length, then something happens. So I'll tell you what happens in just a second, but just want to make sure everybody sees what's going on. We measured from here to here, maybe got 6 inches. And then we measured from here to here, and also got 6 inches. So this chord is congruent to that chord. Okay, so then what happens is the arc is going to be congruent to the other arc. So I'm saying that if this equals this, if those two straight line paths are equal to each other, then it's also true that the curved paths are going to be equal to each other. Which makes sense. If the straight line paths are equal, it makes sense that the curved paths would also be equal. They'd be slightly longer than the straight line paths, but they would be equal to each other if the two straight line paths were equal. All right, one more theorem. In a circle, if a diameter is perpendicular to a chord, in a circle, if a diameter is perpendicular to a chord, so something happens. I know you're dying to find out what happens, but just hold on a second. Let's draw a picture for this situation. So we need a circle. And then we need a chord. And then we need a diameter that's perpendicular to the chord. So I have to go through the center. So there's a diameter that's perpendicular to the chord. So if a diameter is perpendicular to a chord, what happens is then it bisects the chord. It's been a while since we had that word bisect. What does that mean? Yeah, Taylor? Cuts exactly in half. Good. So apparently the chord gets bisected. So here's the chord. So that means this piece is equal to that piece. And it also bisects the arc. So what I mean by that is, here's the arc, and it got cut in half. So this piece equals that piece. That happens if the diameter is perpendicular to the chord. Obviously, if the diameter was like this, it wouldn't cut the chord in half if it wasn't perpendicular. But since it is perpendicular, it's going to cut the chord in half. Everybody okay with all that? All right, that's it for the note card. The title of today is Geometry 9-3 Day 1. And we're going to start with number 1. There's a picture of a circle. You don't have to draw the circle. All right, so there's the picture, and they're talking about arc QR. So here's arc QR right here, the curved piece. And the question is asking us to name another arc that's congruent to that arc. So here's arc QR. We need to name another arc that's congruent to that arc. Yeah, Maddie? QM is congruent to that arc. Good. So how do we know that this arc is congruent to that arc? Yeah, Taylor? So this is getting bisected, right? Or sorry, this is getting bisected. How do we know for sure that it's getting bisected? So that's good. Good use of the terminology bisect. But how do we know for sure that it's getting bisected? Yeah, Judah? That 90-degree angle is a big deal. The fact that the diameter is perpendicular to the chord. So this just said, if a diameter is perpendicular to a chord, then stuff gets bisected. So here we have a chord, here we have a diameter that's perpendicular, so that's how we know for sure that things are getting bisected. Okay, in question B, they're giving us some more information. They say from P to R is 13. So that line right there, 13 inches or centimeters or whatever we're measuring in here. Okay, then they want us to find how far it is from P to M. So they told us from P to R is 13. And then the first question is asking how far from P to M. Yes, Emma? PM is also 13, good, because it's the same as this. How do we know for sure that this line is the same length as that line? Yeah, Kieran? They're both radiuses of the circle, right? If you start in the center of a circle and go out to the edge, it's going to be the same distance no matter how you get there. The center to the edge, center to the edge. That's how a circle's set up, right? Center to the edge is always equal. So PM is a radius of the circle, and so is PR. So that's why they have to be equal. All the radii of a circle are the same length. Okay, so that's why PM is 13. So then how far from P to Q? Yes. Also 13 because it's another radius, right? That one's a little bit stranger because there's a line cutting it, but still from P to Q is 13. So how about T to Q? Yeah, Judah? 26, because it's a diameter, right? So it's twice the radius. So this question was basically saying all the radii of a circle have to be the same, and then the diameter is going to be twice as big. All right, now we got some more information. In part C, RM is 24. So they're saying from R to M is 24. And they want to know how far from R to O. Oh, I forgot to mention, we haven't seen this notation in a while, but remember, RO means the distance from R to O. Okay, so what is the distance from R to O? Thank you. Yep, 12, good. Just half of 24, right? So I'll label that 12. How did we know that this chord was getting bisected? Because the diameter is perpendicular to it, right? So that's why this 24 got cut in half into 12 and 12. All right. right, next they want to know OM. And of course, O to M is also 12. Okay, last but not least, they want to know how far it is from O to P. So from there to there, how far from O to P? Any ideas on how we can figure that out? Yeah, Rachel. Good, Pythagorean theorem. This triangle here is a right triangle, right? So we can do leg squared plus leg squared equals hypotenuse squared. But in all the mess, it's hard to see the right triangle, right? But it is a right triangle. So x squared plus 12 squared equals 13 squared. So difficult to see that right triangle because there's so much going on in the picture, but Rachel was able to see that that was a right triangle. So you just square out 12 and get 144. Square out 13 and get 169. And then subtract the 144 over. And that comes out to 5. So the length from O to P is 5. Okay, new circle on number 2. Didn't really get that in the center. C is supposed to be the center. All right, here's the information we have. They told us BC is 5. We don't even have that drawn in yet, so I guess go ahead and draw that in. BC is 5. And then they told us EF is 2. So that is 2 in there. And they want us to find how far from A to B. So we have a little bit of information. We know that's 5. We know that little piece is 2. We need to find that distance. So how far from C to E? Yeah, Karen?
5.
5 because it's a radius, right? See how C to E is a radius? So then how far from C to F? Yep.
3.
3, good. Because if the whole thing's 5 and one little bit of it is 2, then that has to be 3. So then I can put an X here, and this is a right triangle again. So x squared plus 3 squared equals 5 squared. So x squared plus 9 equals 25. So the x comes out to 4. So this piece up here is 4. So then how big is this piece? 4 as well, because the diameter is bisecting the chord. So then from A to B is a total of 8. Everybody doing okay? All right, one last question. This is number 4. There's some words that you have to digest in number 4. So it starts out, a chord of a circle is 10 inches long. So don't have to write this sentence down, but you should draw a picture. A chord of a circle is 10 inches long. So go ahead and draw a circle. Sorry, I got a little lopsided over here. Do the best you can. So there's a chord that's 10 inches long. I guess I'll put it here. And then it also says the chord is 10 inches long and 12 inches from the center of the circle. So the chord is 10 inches long and it's 12 inches from the center of the circle. So here's the center of the circle. And apparently from there to the chord is 12 inches. So if you were standing at the center of the circle and you're trying to get to the chord, how would you go? Would you go like that or like that? How would you get from here to the chord? Would you choose to go this way? Why not? Because it's not the shortest path, right? If you were going to go from there to this, you'd want to go like that, straight there. So the point I'm trying to make is if you go from the center to the chord, it's going to make a 90-degree angle. So that distance is 12 inches. Okay, so then I could draw in the rest of the diameter. So what does that diameter do to that chord? It bisects it because it's perpendicular. Okay, so now that 10 just got split up into 2 5s. Because we just learned today that the diameter, if it's perpendicular to the chord, it's going to cut it in half. Okay, the question here is find the radius of the circle. So that's kind of awkward because there's not even a radius drawn in yet. So I'm going to go ahead and draw in this radius. And the reason, I could have picked any radius. Could have gone this way or that way. But the reason I picked this one is because then I get a right triangle here. So here's I'll put an R for radius. And then since I have a right triangle, I can do Pythagorean theorem. So this time it's 5 squared plus 12 squared equals R squared. So you figure all that out and you get 13.